Welcome back. It looks like it's a filament dryer week on my TechFun YouTube channel because I will have 3 in quite short period of time. This is Sovol SH02 and this box is sent to me by the Sovol company in exchange for the review, but there is no additional payment to create this video. However, this video is still sponsored, but not by Sovol, but by Polymaker, who became a channel sponsor in the meantime. The price is approximately $60, which is quite good price for these specifications. It can accept 2 1 kg spools. The diameter is 200 mm by 70 mm, or one bigger spool. The diameter is still 200 mm by 150 mm. The maximum temperature is 70 degrees Celsius, and it has a 150 watt PETG heater, which can circulate the air inside. And it has preset values for each filament type, and it also has temperature and humidity sensor. This is the older version. Maximum temperature here is approximately 50 degrees Celsius, but I'm still using it because it can accept wider 1 kg spools, but also it is the quietest filament dryer which is equipped with a fan. Very shortly, why do we need a filament dryer? Well, I will just show you a few pictures. These are my own PETG wet and dry state, and we can see quite a lot of stringing. This is PETG. Here we don't have the stringing, but we can see quite a lot of overextrusion on that surface. And also nylon and TPU are very sensitive to this moisture. In this case, even the printing I'm doing from the filament dryer. Now those 70 degrees Celsius are enough to dry almost any filament type, even the nylon, but in this case it is very important to store that nylon properly on very dry place. In that case you can dry it maybe in 1 day. And I explain this in a separate video. What will I test? Well, I have my sponge drying experiment when I will measure the weight of this sponge after half hours and after 1 hour. But actually here, collecting the data about the temperature and relative humidity is more important for me, because these 70 degrees Celsius dryers can dry this sponge in half hours completely. And another test is when I'm checking with the thermal camera the temperature of the spool after 10 minutes. Because I always suggest to the companies to integrate some kind of rotating of the spool during this drying. But I got some comments and feedback that these PETG heaters, which circulates the air inside, will make the air temperature more equal, but not after 10 minutes, but let's say after half hour. So this time I will check the temperature of the spool, but not after 10, but after 30 minutes. And we will see how equal is the drying of the filament. Content of the package is very simple. We have the user manual, 1.5 meter AC cable, and the unit itself. These are rollers inside the ball bearings and they rotate quite smoothly. And this is the space for the desiccant. Not too deep, and unfortunately the desiccant is not included, at least in my package. According to this picture, the hot air inputs here and goes out on the opposite side. But look at these openings. The hot air input is in the center of the dryer, and on the other side it is on the left part of the dryer. This means the temperature is not spread equally, well, except if I place my wider spool in the center. The sealing is very good. Even around this frame we have this rubber. I'm not sure if you can see it on the screen. This means we can use it as a storage too. This opening is very important to leave open if you dry the filament. If you store it, then you have to close it. And these openings are exit for the filaments. The main switch is on the back side. And on the front side we have the screen. Let's turn it on. The previous version was quieter. Operation is very simple. This is the power switch and this is a setting. With this I can change the position of this cursor and then I can change this value. For example, I want to change the preset values for PLA or other material. Or if I'm not too happy with this preset value, I can change it. And here I can change the countdown time. It's time to start with my sponge drying test. This is the position of the DHT22 sensor. It's a little bit higher than usual, but I'm quite limited now with the length of this wire. And also I took out this sealing because it is from plastic and I don't have enough elasticity to push through it 3 wires. This way will be open so I can let out the moisture. I hope this Kapton tape will hold the sensor until the end, and there will be the position of the sponge, approximately in the center of the spool. I also inserted 2 desiccants, but they don't really help with the drying of the filament. Yes, they help with the storing of the filament after the drying. And data will be collected with this Arduino Uno and the serial monitor on this laptop, and the current state I can see on this screen too. And since this is a bigger dryer, always get a request to insert a spool next to the test object. Weight of the dry sponge 0.568 grams. And I'm adding exactly 2 milliliters of water, but I'm measuring the weight, it's more accurate. 2.601, close enough. The noise from half meter distance is approximately 47 decibels, but that's not too big value. But what bothers me more is that high frequency sound, which I don't really like. I think their temperature sensor is on the opposite side, because according to mine it is 63 degrees Celsius inside after 5.5 minutes, according to their 53. This means if you set the temperature to 70 degrees Celsius and the sensor is on the colder side, what will be the temperature of the hot air? I hope not too much higher. I have to take out the filament because it is pushing the sensor. According to my sensor, they reach 70 degrees Celsius in a little bit more than 9 minutes. According to their own, it is 62. We will see what will be the peak temperature inside. And now, after approximately 15 minutes, it reached the 70 degrees Celsius according to its own sensor, and probably it will start turning on and off the heater now. According to my sensor, it is 76 degrees Celsius inside, which is okay, but later I will check directly the temperature of the hot air, because currently my sensor is quite high. It's time for the half hour measuring. 1.228. Time for 1 hour measuring. 0.552. A little bit drier than at the beginning because it had some moisture in it. Before I turn it off, I want to measure the temperature of the direct hot air. Which on this point is 88 degrees Celsius, which is a little bit too much. During this 1 hour, I measured the power consumption with this smart plug, and it was 0.07 kilowatt hours, including the heat up time, which is quite low value. One more temperature measuring. What happens if I set the temperature to 60 degrees Celsius? What will be the maximal temperature of this hot air? As you can see, it is quite close to the spool. The temperature is set to 60 degrees Celsius, which is preset value for the PETG. Pity I didn't collect the data with the Arduino. The temperature varies from 80 as a peak down to 70 approximately, or even lower. And the temperature is set to 60 degrees Celsius, so it's a little bit too much if I set the temperature for PETG drying. And I think the reason for this big inaccuracy is that their sensor is behind these holes, and here is the exit of the air, and here it comes in, which is much hotter. So until it goes on the other side, it cools down a little bit, and that's the temperature which it follows here. So my suggestion, if you want to dry PLA or PETG, set the temperature first and wait until the temperature stabilizes, and only then insert the filament. The nylon is safe. I mean, those 80 degrees Celsius is even better for drying of the nylon. Let's analyze the temperature first. It started with the heating, and here I noticed that the spool is pressing the sensor against the wall, so I took it out. And then after 15 minutes approximately, it reached those 70 degrees Celsius according to its own sensor. According to mine, it was 77. And these waves are here because it's turning on and off the heater. Here it was open for 30-minute measuring. I did it quite quickly, so there was no big change in the temperature. And here it was open for 1 hour measuring, and actually I turned it off here. But pay attention to this relative humidity. Here I took out the spool and I let out quite a lot of moisture. And when it reached these big temperatures, then it pushed more moisture from the filament, and look how the relative humidity increased. And I let out quite a lot of moisture by that opening for 30-minute measuring. And again it continues pushing the moisture out, and it was open for 1 minute measuring. Of course the situation is not this bad, because by drying the filament you don't have this big amount of the moisture, but it is good to know that the moisture will stuck inside that hole on the top is not big enough. And this is the result of my sponge drying test, and these numbers will be added to the summary page on my website. Time for the thermal camera test. This is Easy PA or Nylon by Sanlu. I have the test in progress. So I will not rotate it during the drying, and it is located on the left side, which is the better side in this case. Set to 70 degrees Celsius, and the measuring will be after half hours. It's time to prepare the thermal camera, and first I will analyze it from outside. This is the front side, and we can see that the left bottom side is hotter because there the air goes out. And this is the side, and yes, we can see on the back side that hot air comes in, and it's significantly hotter from outside. And now let's analyze this spool. I noticed 15 degrees Celsius difference between the coldest and the hottest point. Well, it's quite obvious that the heating is not equal, even after half hours. But at least the manual rotating of the spool is quite easy. And now that like don't like part. There are many things which I like about this dryer: very affordable price, very low power consumption, and it can accept those wider 1 kg spools which I have. Also, even if it doesn't rotate the spool automatically, I can do it very quickly manually. The unused volume is also smaller on this dryer, which additionally helps with this efficiency. And now what I don't like. First of all, the noise. And it's not only about the decibels, but the frequency of that sound. I don't know why the filament dryer companies are continuing to ignoring our requests, but something which will operate continuously almost. I mean, you will dry the nylon 10 hours one day, and definitely you don't want to be in the same room with this dryer. The second thing is that the temperature of the hot air. The sensor is probably on the other side. Maybe this is the reason why the input of the hot air is quite high, which is good for the nylon, for example, because we can dry some nylons even 120 degrees Celsius. I tested this earlier. But if you set 60 degrees Celsius for the PETG or 50 degrees Celsius for the PLA, definitely you don't want that hot air to be 80 degrees Celsius. Solution for this is actually to wait until the temperature stabilizes and only then insert the filament. And maybe one more thing to mention, it would be good to include some Teflon tubes, for example, and not only to connect the dryer with the printer, but to protect this plastic. I'm not sure what is the material of this part here, exit of the filament, but let me show you, even some Teflon tubes cannot withstand those carbon fiber, nylon or polycarbonate filaments, which acts like a sandpaper. And soon I will have one more filament dryer review video, but this time not sent by the companies, but sent by one of my viewers who created a very nice DIY solution. And if you like this kind of videos, then maybe you should consider subscribing and enabling that notification bell button too, because in most cases my videos are only recommended to those who enable that notification bell button. Anyway, thank you for watching this video, and I know, happy drying and printing.